Alrighty, let's see what we got. Hard. Okay, time to end this streak. Or maybe continue it. Number of ways to divide a long corridor. Along library corridor, there's a line of seats and decorative plants. You're given a zero indexed string corridor of length n, consisting of letters S and P, where each S represents a seat and P represents a plant. Okay. String of seats and plants in a corridor. Okay. One room divider has already been installed to left at index 0 and another one at index n-1. Additional room dividers can be installed for each position between indices i-1 and I. The most one divider can be installed. Okay, sure. So in theory, that means you could have a divider initially, I think. Divide the corridor into non-overlapping sections where each section has exactly 2 seats with any number of plants. There may be multiple ways to form division. 2 ways are different if there's a position with a room divider installed in the first way but not in the second way. Okay, could be a large number, turn mod. There's no way, return 0. Okay, I think I need to look at some examples here. Divide the corridor into non-overlapping sections where each section has exactly 2 seats. There may be multiple ways to perform the division. 2 ways are different if there's a position with room divider installed in the first way. So dividers denote the difference. So you can have 2 seats, a divider here, or here, I think. So the divider can be 2 seats. There must be 2 seats or exactly 2. Okay. So here, here. And you can't actually put a divider here because there's no that would cause this to be not 2 seats. And this is 0. Interesting. I mean, to be honest, this doesn't seem hard. I think it feels like a medium. But maybe as I start working on it, it'll actually become obvious why this is hard. Okay, so how to approach this? So I think the first example is pretty good. So in theory, so they came out with 3. So it could be here, here. So if you see 2 seats, right, that's going to be the earliest where the next divider can occur. So the next divider can occur here, or here. So that's 3. And then what does that mean? And then how would you extrapolate from there? You have to go to the next. You have to immediately go to the next spot where a divider can occur after 2 seats. If there is no next spot, then there's totally 0. But if there was a next spot, so let's say, so this is equivalent to seat, plant, seat, right? This is example 1. So there's like 3 spots, a divider here, here, between somewhere around these 2 plants. And then technically it's like 0 once you see this seat right here, because this means that the last kind of last area. That means the last area is just has one seat within it. So you have to go to the next area, or you have to go to where the next completion of 2 seats is, so it'd be here. So if it was like, let's say it was followed by another plant here, or maybe another 2 plants here. Or let's go another 3 plants here. So in theory there should be 3 dividers here, 4 dividers possibly here. 1, 2, 3, 4. So it should be like 3 times 4. Any of the first ways with any of the second ways. Okay, let's go ahead and do a test case for that. I think my answer will be 12 there. So if this was followed by 3 plants, yeah, there'd be 4 spots there. Oh boy, it's not 12. Oh boy. Ah, that's right. That's right. Yeah, there's only one way. The thing has to be here in order to actually have 2 seats in the last section. So it's just the middle 3. 1, 2, 3. So it's the middle areas that actually matter. The end sections need to have, like, there can't be anything. Anything between the end divider and the kind of the first. I'm not sure how to say this, but from the left side and from the right side, you need to go to at least 2 seats in, and that's when you actually can look at things, because everything else is going to be fixed. You can't actually start earlier than that or end later than that. Like, you can't have a divider in these spots because that would just create something that doesn't have 2 seats in it. Interesting. So I mean the endings are different, but then the middles are probably free. Yeah, my eyes are so watery now. Okay. Wonder if I can. I wonder. Maybe I can still go forward, do a forward-looking one, ignore the last section of values. So if the last section of values is 4, then just ignore the 4 and say that it's the 3 before it. Also check. My test cases are just probably not good enough though. This has to be a reason why this is hard. But I think maybe, okay, so I'm going to count the number of things after I'll do a while loop. Well, I'll do a for loop, and then once I get to 2 seats, I start counting. Or I can do a while loop while I go through sections 2 seats at a time. How long is this string? How long is the corridor? It's going to be 10 to the 5th. Okay. So I think I just need to divide this up into sections of like spots where the actual things can occur, the dividers can occur. So let's say open counts. I'm just going to try to track the number of positions where the dividers can occur between the required 2 seats. Like, I guess this would be the second seat, the fourth seat, so like between the second, third, how many plants? Between the fourth and the fifth, how many plants? So between E and E plus 1, E I guess nth and nth plus 1 this is going to be the counts of plants between seats nth and n plus 1 where n is even. So like the second and third, fourth and fifth, sixth and seventh, if there is any. Okay, so I think I can just use. Should this be a while loop or a for loop that I go through? Feels like a while loop because you're kind of jumping over. Then you maybe can use a for loop. Wonder. Do I need to maybe mimic? Do I need to? Okay, let's say seat count starts at 0. So I guess maybe I can still use this as so there might be between the 0th and the first seat there's some number here. So there's like 1, 2, 3. And then between the second and the end there's 2. But if you ignore those because it's not possible to put dividers in those spots, then it's just 1. So I think maybe correct 0 for every index in range n, where n is the length of corridor. If the string at this index is equal to a plant, then the current amount of plants in this section is going to be incremented. Else what? No, it doesn't get incremented. Yeah, I guess I can still increment here. Else, I know eventually I want currents set to 0. So here this means I see a seat. So the seat is going to reset the streak of plants between seats, or the count of plants between streets, and change the seat count. So seat count should increment. And I think if I say that if this current seat count is now odd, So this means if I go from 0 seat count to 1 seat count, so initially seeing this one, then whatever the number of plants here needs to be added to the open counts. Now this is an odd number. And then open counts dot append the current amount before it resets. So this would put 2. Okay. I think maybe. Alright, let me see what this prints out for me. I think I might be able to work with that. So here it's counting. So 0 here, 2 here, and it doesn't append this thing because it reached the end of the thing. So that's correct. That's what I wanted. This should append 2 and 1. Oh, it doesn't append the last thing, so it just appends 2. This thing doesn't have anything. And the last test case, this should be 2, 1. No, sorry, I'm looking at the seats. It should be 0, 2, and that's it, 0, 2. Okay. I think maybe if I did a test case again, based on the last one, maybe add another seat, it should be 0, 2, and 3. 0, 2, 3. Okay, sure. Okay, so first things first is, I think if the current seat count is odd at the very end of this, that means that it's not possible, right? Because then I have like an open thing at the end. If seat count mod 2 is equal to 1, it's odd, return 0. That just means the last kind of last divider. Oh, that's not right then. Yeah, I got these 2 test cases. Yeah, there's no place for last divider. Okay, so then it boils down to the other places. I think I probably want to, I think I need to ignore the first grouping because that just can't work. The first spots where the dividers could occur, because that would create something with 0 seats. So ignore the first open spots value, but then every other value in between them should be multiplied together, and then you have the mod. So I think something like for every index in range 1 to n, not 1 to the length of open counts, my answer should be multiplied by that value, or my answer starts with 1. Answer equals answer times open counts at this index, and then mod, and then return the answer. Ooh, okay. Not getting the first case right. Oh. Yeah, there's 3 spots here. Wonder why. It should definitely be n multiplied by the index, the open spots plus 1. I wonder how the other one even worked. This is my issue. Yeah. Kind of concerning. That's a pretty big logic issue. Guess this was empty. I guess that, yeah, the only thing in the middle was 1. Okay. Well, I think let's give it a whirl. What's going on? Well, I solved most of the test cases, which is good. This is kind of concerning. P. So it sees a plant. I see. Yeah. So if it actually never sees any seats, even if that's an even amount, that's not actually valid. So I think it just needs to be if the seat count is 0, or I guess if I do seat count 0, so it should be not seat count. I could do, yeah, whatever. Let's go ahead and add that as a test case. I guess maybe I should check my initial conditions to see if that trivial kind of case is possible, and yeah, it definitely is possible. I mean, maybe I assumed that there was going to be at least 1 seat. Whatever. Interesting. Okay. Yeah. Okay. So I guess my suspicion that this was more of a medium difficulty was not far. I mean, definitely felt medium in terms of how I was thinking about it. Okay, so the main thing here is just speed, and I think I can easily improve this by just not creating the open counts, keeping track of that, kind of running multiplication answer value without using open counts. I think open counts is useful in terms of like when you do a problem, you like to have some sort of output that you can work with, that or you can do the logic on. But then once you see how the logic is performed, you can kind of go back and kind of remove stuff or optimize or make things more efficient without having to resort to those things as kind of temporary holders of values. But certainly would have been much tougher to code this, having to track everything in my head. So that being the case, though, I am going to remove open counts to make this a little faster. So open counts really is only is appended and then the answer is multiplied. Okay, so I think maybe I can let's say answer equals 0 here, or answer equals 1 here. I'm going to have to skip over the first one. I have to skip over the first one. So that's so I can either track that separately, do a for loop separately to find the first index after the first two seat occurrences. So maybe I can do like start equals 0 and then how to do this? While seat count is less than 2 and start is less than n, and start is less than n. I can do something like if corridor at this starting index is equal to a seat count increments, and always start index increases. Okay, so this is going to try to skip over the first block of plants that can't be divided. And then I think I need to verify that this is valid here. So if this reaches the end, then this is not valid, I think. If start equals end, because there's just no way it should reach the end. Otherwise, I guess if there's two seats, seat, start is reaching the end. Actually, so if start equals end, then return 0 if seat count, actually return 1 if seat count is equal to 2, else return 0. Okay. So I think that covers either not having enough seats at the start, so like a bunch of plants, or a bunch of plants in one seat somehow. If there's exactly 2 seats, then this should work. Or if there's 2 seats and a bunch of plants, then this is not going to reach this if statement here. Okay, so this is going to be for skip initial block of plants, or skip initial area spots before second seat. Not possible to divide, well, earliest divider is after second seat. Okay, I think that's fine. So then I think here start equals seat count equals 0. Maybe I can call this index, to be honest. Yeah, that's fine. And I'm going to comment this one out. Current is the current count of plants between, or I guess this is current count of plants between seats. Actually, this is just not even or odd seats. This is just any seats. Yeah. So for index and range from start onwards, the corridor at this index is equal to a plant, then increment the current count. And then otherwise increment the seat count. If the seat count is now odd, then it's going from even to odd. Then I do the logic. Where the logic is to modify the answer by this kind of possibility. Answer times 1 plus the current. And then reset the current mod. And then here I can ignore and go back to ignoring just if the seat count is odd. Then it's not possible because I'm dealing with an ending area that cannot fit 2 seats. I think this just goes away. Okay. Okay, so I think I modified it to get rid of the open counts array correctly, hopefully. Oh my lord. Still not fast enough. Interesting. I wonder if I use split. Like there's some technique here that I'm not using that's faster than what I'm currently doing for the counts. I think it might be that I should be splitting. If I split based on p's, maybe that's gonna be faster. Split syntax separator. Pass in a separator. Just deliver used to split the string. If not specified, any white space is used. I wonder, what happens if you split based on p's? Let's go ahead and print. Splitted would be corridor, not split based on the p's. No, based on the s's actually. Okay. Yeah, that might work actually. So between every occurrence of s, or I mean, it might work in the sense that I could probably work with this array and use some logic here. The length, maybe. Right, so the first s before is there's nothing. Between the first and second s, there's nothing. and then between the second and third S there's two P's. Third and fourth S there's a P, and after the fourth S there's nothing. So I ignore between the first and second S. Between between the 0th and the first S. So ignore the front, ignore the back. And then what? And then I'm multiplying the length 1 times, keeping the running total 1 times the, or keeping the running total of the answer times 1 plus the length of every other remaining string within the splitted array. Is there one that's actually non-trivial here? Okay, they're all kind of not the best test case to see this. To see this logic. I think if I just remove this S here, it works to be a test case that's usable to see stuff non-trivially. So I ignore the first and last strings, and then I do this one. So I skip this one, skip this one. Okay, so I think the split operation is pretty fast, to be honest. It's probably faster than trying to keep track of everything using this thing. So, test case of the single P, there is I think if there's less than, so if there's 2 S's within it, then the length of the split it should be 3. So I think if there's less than 3 length of the splitted, then it's not possible. Less than 3, right? Because then there's 1 seat or there's 0 seats. Less than 2 seats. Right. And then everything else is valid. So I ignore the front and last. So I think I start with index. So I think I start with answer 1 for every index in range 0, 1, range 2. Where does it end? It ends in 1 less, range 2, ending values going up by 2. Should be something like answer equals answer times 1 plus splitted, or the length. The length of splitted at this index, and then mod, and then return this answer. Just need to figure out what the ending index value is for skipping over the things. So this is going to be 3 or 0, 1, 2. So yeah, it's going to be 2. I think I need to make a. I think it only works if it's an odd number of. No, 1, 2, 3, 4, 5. Yeah, there has to be an odd number of entries here. Otherwise, there's there's an odd number of plants, in which case it's not possible. So I think here split is less than 3, or length of split it is odd. And it's not possible. Not possible if not possible if if there's an odd number of plants, in which case splitted split length is even. No, split length is not possible. Odd split length should be even in that case. Yeah, whoops. So if or the split length is even, we can move backwards. Okay, so in any case, what is the ending index? So going from 3 or 0, 1, 2, 3, 4, I think it might be length is splitted minus 1, because you can't actually end the spot. Is that right? I think that's right. I'll give it a whirl. Length of splitted minus 1. Oh yeah. Okay. Sweet, sweet, sweet. Okay, so I had to go through a couple of possibilities there, but found it. Man, this looks pretty simple. Alright, summary. Okay, so went through a couple of iterations of the solution or a solution. I've got some of my solutions. First, I guess initially attempted to track count of open or track count of plants between seats, ignoring the first and last counts before, since dividers can't be placed before and after the first and last seats, because then you'd have a section that has 0 seats in it at the start or end. The answer is multiplied by, or the running answer value is multiplied by 1 plus current count, or the count of seats. Primarily, the first example shows this, so after the second seat, 2 plants, there's 3 spots. So it's 1 plus the count seats, count of current plants. Skipping over counts for counts between or only for counts. Only for counts between even and odds, or and even and odd seats, like second to third, or 10th to 11th, since an odd to even count, those plants are ignored, you can't put a divider there. Eventually, but since that wasn't fast enough, use the split command function on the quarter string, splitting at where the plants are. Then did similar logic based on the length of the strings of plants that remained after splitting. So if you know that you need to have 2 seats at least, then you know that the number of things between those 2 seats, there has to be at least 3 of them. That's game condition. If you know there needs to be an even number of plants, then you know that the length of the split has to be an odd number. So therefore, if it's an even number, then there's going to be 0 ways of doing that. It's the first logic. And then the main logic is just the multiplication of the values of the counts of the plants between those even seats translates to be the lengths of the strings within that splitted array, every other one. So just use a for loop to go over those values. Anyways, time complexity, this can be O of n to split the array, to split the string, and then same time to kind of iterate over those, iterate over the splitted. Is that called spliced? No, it's not spliced. The divided strings to find the value, to find the answer value. Space complexity, this can be O of n to have an array of splitted substrings. Alright, cool beans.